Well, nice to have you for a lesson on number theory. Now, what is number theory? As we have it stated here, it is used to place numbers into different groups or sets, okay? So it's just a method we use to classify or group numbers. Now, the first set of numbers that I would like to look at is the set of counting numbers, or it is otherwise known as the set of natural numbers. So in school or in class, you may hear your teacher speak about counting numbers, or you may hear he or she speaks about natural numbers. It's the same thing that they're speaking about, yeah, that they're talking about. Now, counting numbers or natural numbers, they start at 1 and goes on forever in the sequence, and I'll show you here. But even before I get into that, I am going to use the capital letter that is used to denote counting numbers or natural numbers, and that is a capital N. Alright? So a capital N is used to denote counting numbers or natural numbers, and this is a N now, guys. Alright? So the set of N numbers, which are counting numbers, and when we're representing a set of numbers, we always use curly brackets, and it starts at 1 and it goes up to 2, 3 in the sequence, 4, 5, and I think you would get the basic idea there. And so I'm going to put three dots rather. These dots means ellipsis, means that it continues or it goes on forever. And now I'm going to close my curly brackets. Okay, so the set of N numbers, number 1, 2, 3, 4, 5, are called counting numbers, and that's how they are represented. Okay, and as we say, they go on forever, so that's why we have underlined this word here, forever. Now the next set of numbers, the second set of numbers that we're going to be looking at, are the set of whole numbers. Now whole numbers now begin at 0 and they continue forever following the pattern. And again, before I show you the pattern, I'm going to show you the letter that is used to represent whole numbers. And representing whole numbers, we use a capital W. Okay, so here I am going to use a capital W to represent my set of whole numbers. Oops, let me just get that. Capital W. Alright, and the set of whole numbers, and I use my curly brackets again, starts at 0 and it goes up in increments of 1 unit. Okay, so that's 1, that's 2, again that's 3, that's 4, that's 5, and I'm going to go up to 6 this time. And now, instead of putting my 3 dots to show continuity, I am going to put a sign or a symbol, and this symbol that I'm using, it looks like a 8 lying down on its side, and that symbol simply means infinity. So wherever, whether in books or on an exam paper, you see this sign, it means infinity. It simply means then the thing or the sequence or whatever you're dealing with, it goes on forever, it continues forever. Okay, and you see me underline that word, forever. Now I'm going to close my curly brackets. So that's a set of whole numbers. Now quickly, if you should make a comparison, another definition that you may see in books for whole numbers would state that whole numbers, and I want you to make a comparison now, that whole numbers are the set of natural numbers or counting numbers inclusive of 0. And if you should look carefully at these numbers here, 1, 2, 3, 4, 5 goes up to infinity. If you should look carefully at the set of whole numbers, you would also see those numbers, 1, 2, 3, 4, 5, 6, and it goes up again to infinity. But the only difference with the group or with the set of whole numbers is that we have added the digit 0 to that group. That makes it a whole number. Thus it is called the set of whole numbers. Now that's just a critical comparison I would like you to capture. Now let's move on to our set of integers. So our third group of numbers that we'll be dealing with today is the set of integers, and integers are please, I have a double R here. Let me just draw my pen through one of them quickly. Now the set of integers are all the negative and positive whole numbers from negative infinity to positive infinity. For example, and I'll state the capital letter that is used to denote integers, and it's a capital Z. So wherever you see this capital Z, it simply means they're speaking about the set of integers. Now let me open my curly brackets, because when dealing with sets of numbers, it's very important to use your curly brackets. Now if it's a set of whole numbers, that means I'm speaking about the previous group here that I have stated. Now, if you notice carefully, I am going to use my negative, and that's my, oops, let me just clear up that a bit. Now I'm going to use my negative infinity sign at this side, and I use my negative infinity sign at this side to show that I'm coming from a negative value way down there. I'm going forever in a negative direction, okay? And I'm going to put a comma, and let's say I started at -3. Then I would go up. Since I'm dealing with whole numbers, I am increasing by 1 unit. So I would have a -2, then I would have a -1, then I would have a 0, then I would have a +1, +2, +3, and I can stop there. So what I'm going to do here, I'm going to put my positive infinity sign. So if you notice, and just picture the number line in your head if you're not seeing it. If I'm going to my left on the number line, I would be going a negative direction forever, okay? And if I'm going to my right on the number line, I would be going into a positive direction forever. So this is simply what it's saying. I am going to a negative direction, so I use the negative infinity sign to suggest that, and also the positive infinity sign to suggest that I'm going in a positive direction. So those are our 3 first sets that we're looking at, and let's look at the fourth set of numbers quickly. And the fourth set that I'm dealing with, this set is called the set of rational numbers, okay? And the set of rational numbers are basically numbers that can be expressed as a decimal or a fraction. For example, and before I state the set before I state the set of rational numbers, I'm going to use the capital letter that is used to denote rational numbers. Now, rational numbers can be denoted by using a capital Q. Okay, so wherever we see this capital Q and they're speaking about a set of numbers, they're speaking about rational numbers. Now, curly brackets, I must open my curly brackets, and if I'm speaking about numbers that can be expressed as decimals or fractions, then a half is a fraction, so a half is a rational number. Okay, 0.25, for example, is a decimal, can be expressed as a decimal, so that's a rational number. We could look at 5/3. That's a fraction. That's an improper fraction. It's also a rational number. We can look at, for example, 2 1/4. Okay, that's also another rational number. Let's look at a negative number. What about -3? -3 is a rational number. Well, some persons may say, no, this is not a rational number. It is an integer. Well, look at this carefully. We could express -3 as -3/1. Okay, so this is a rational number because it can be expressed as a fraction. What about +5? Some persons may say, no, +5 is a whole number, but +5 also can be expressed as a fraction by putting it over 1. So any number can be expressed as a fraction by putting it over 1. So these two numbers, or these two exceptional numbers, they are also rational numbers. So what I'm going to do now, I'm just simply going to close my... So that's our lesson on number theory. We have just looked at the 4 first types of numbers. Now join us in our next video when we complete the next set of numbers on number theory. Bye bye.